So if you guys remember a lesson we did a couple weeks ago, I'm not going to ask you to tell me all about it, but do you somewhat remember doing SPA? We wrote some ratios, we did some things to them. Like for instance, you don't need to write this down. Let's say our sides ratio was 3 to 5. The perimeter ratio was exactly the same. Anybody remember how we found the area ratio? You squared it. 3 squared is 9, 5 squared is 25. We're going to kind of do that today, but we're going to expand it to volume. Really no different, same process. Any guesses on what I do with this to get volume? Cube it. 3 times 3 times 3. I can use a calculator. I would get 27. 5 times 5 times 5. I would get 125. So it's going to be very similar to a different lesson that we've learned. Here's a quick visual. Let's say I have 1/2, 1/2. This would be a 4th. This would be an 8th. Here's a visual I showed last time. Regular 8.5 by 11 piece of paper. I have cut the sides in half. I did exactly half. I used a ruler and everything. The sides are cut in half. Sides, a half. Is the area cut in half? You tell by looking, no, right? It's cut in 4ths. So we have to be careful. If it says the box is cut in half, or I should say the box. If something is cut in half, one of the sides, the area is not necessarily cut in half. The area ratio will be 1 to 4. So in your notes, if you would, under sides, let's write A to B, because we don't know the numbers. Let's just say the numbers are A and B. The perimeter ratio is going to be exactly the same. Area is going to be squared, so we don't know the number, but just write A squared over B squared. In volume, A cubed over B cubed. First thing we're going to do is make sure our figures are similar, because we don't want to compare this figure to this figure. We can't say, oh, this is 3, this is 6, this is twice as big, area 4 times as big. They're not even the same shape. Well, they're both triangles, but they're not similar. This is a right triangle, and that's not. The figures have to be similar. So example 1, we're going to see if they are similar. Example 1, determine whether the rectangular prism on the left is similar to prism A or B. Pretty simple process. Let's look at 5 corresponds with 15. Doesn't matter which is on top. Now that I've put 5 on the top, this figure has to be on the top every time. 3 corresponds with 9. And my last side, 7 corresponds with 14. I think we can simplify in our heads. 5 divided by 15 is a third. Are allowed to use a calculator though. 3 divided by 9 is a third. 7 divided by 14 is a half. Do you think these figures are similar? No. One side got a third as big or 3 times bigger. One side got 3 times bigger, and one side got half as big. That's not similar. Not similar. Imagine taking a photo and enlarging the height by 2 and the width by 7. That's not going to be similar to the original. Every side has to be multiplied by the same thing. Let's do the same for B. 5, 10. Keep going. Find the next side and see what it corresponds with. everything simplifies to a half, so you can think of the figure getting smaller by a half, or depending on which direction you look at it, this side is bigger by 2. So because every side has the same multiple, yes, this one is similar to this one. I think we can skip over this. We're pretty good at telling if things are similar, right? We got it? All right. We don't need to do example 2. Let's look at example 3. Cylinders A and B are similar with a scale factor of 2 to 5. I would underline scale factor. Make sure you remember what that means. Ratio of sides. So here's what we have. We have 2 cylinders. Unfortunately, we don't get a picture of them. But here's what we know about cylinders A and B. They're similar. Their scale factor, or the ratio of their sides, simplifies to 2 over 5. We are going to find the surface area and the volume of cylinder B. Given that the surface area of cylinder A is 96 pi square feet, and the volume of cylinder A is 128 pi cubic. Now let's pause for a second. We just got done with lessons over there where we did surface area and volume. Do we have enough information here to find the surface area of cylinder B? No. So we cannot just use our formula to find surface area of a cylinder. Oops, that's not one. We cannot just use surface area formula because we don't have a picture, we don't have numbers to plug in and calculate. So what we're going to do is we're going to use what we know about cylinder A because they are similar. Here's how we start every problem. SPA, just like before. Sides, perimeter, area. We expand it. B for volume. Size ratio, perimeter ratio, area ratio, volume ratio. You will always fill in one of these. This one, we know the ratio of the sides is 2 over 5. You will not put this surface area number right here and this volume number right here. You will not do that because we only have one volume and one surface area. We have to have one from each figure. So only fill in what you know of both. We know both of them. If we simplify the sides, it'll be 2 over 5. Now take your 2 over 5 and fill in the others like we did up here. So remember, these are going to match exactly. Area is squared, volume is cubed. So these have to match exactly. This ratio is 2 over 5. What is squared? 2 squared, 5 squared. 2 cubed. You can use your calculator. 2 to the third. You know, if you want help finding that, I think we practiced it yesterday when we did volume of spheres. Then type 5 cubed. Do I need help with their calculator? There's a caret button. Yeah. All right, so step 1 is fill in the ratio you know, 2/5. Step 2, fill in the other ones. Now it's time to actually answer the question. First thing they ask us is, find the surface area of cylinder B. Since they're asking us about surface area, we need to pick the area ratio. So go ahead, rewrite the area ratio. And we should know one of the surface areas and we'll find the other. We do in fact know the surface area of cylinder A is 96 pi. I need to put it on top because it says A and B. It's in that order. So A is on the top, B is on the bottom. And now I can solve for surface area of B. It's been a week or two since we cross multiplied, but it's a skill we've done a lot, so I know you can do it. Go ahead and cross multiply. I think we should label this surface area, so feet squared. And I'm also going to say SA, surface area of cylinder B. What questions do we have so far? $1,884.96. Okay. Cross multiply. Here. Yeah. So 25 times 96 pi. You'll type that in your calculator. Okay, and then write that number down. Then that equals, you got to multiply the other cross, so 4 times x. Then divide by. Good question. All right, we would be done with this one, but unfortunately it does ask us another question. Not only do we have to find the surface area of cylinder B, but it also says find the volume of cylinder B. We've already got some work here. So now that they ask us a volume question, let's circle our volume formula, our volume ratio, and use that. Alrighty, so do we know the volume of one of them? Yes, we do. The volume of cylinder A is on the top, 128 pi. I'm going to use the variable b this time because I don't want to use x again on the same problem. Go ahead and solve for the volume of cylinder B. Questions for volume? Yes.
So how would you know volume? So how do you know?
How do we know to put top or bottom? Yeah. Because in the beginning it said surface area of cylinder A to B is 2 to 5. It's in that order, so A is first, B is second. A is first, B is second. So I continue to always put A first or on the top. But anything else? All right, flip the paper over, please. Example 4, find the scale factor of the two cones. We've been given the two volumes. Let's start with SPA. Size, perimeter area, and then volume. Carter, do you see where we're going to start on this one? What ratio do I know? Do I know two sides, two perimeters, two areas, or two volumes?
Area?
Ooh, right here, two volumes. Yep. So go ahead and put those two numbers under volume. Now we have some simplifying to do. We know pi divided by pi will cancel. So let's practice typing 108 divided by 256. Your calculator will likely give you a decimal. Bring your decimal into a fraction. We have a graphing calculator. Remember, we hit math. Our first choice is fraction. We should get 27 over 64. Now, I don't really want you to erase what you have, but I want you to think about this as one fraction. Don't look at all your preliminary work. Volume simplifies to that. Now, how will I go backwards to get this ratio? Yes. If I had this one, how did I go forward? I cubed it, didn't I? So what's the opposite of cube? Good guess. How do you undo a cube? Yes. Ooh, that's how we undo a square. Ooh, good guess. So the opposite of square is square root. So the opposite of cube is cube root. We haven't done that a lot. Maybe did in algebra 1. But just like we take square roots, you can take a cube root. So this is something you'll need to practice in your calculator. Let me start with those of you that have a graphing calculator. Hit math. Your fourth choice down is the cube root. Hit that. Cube root of 27, you should get 3. Do it again to find the cube root of 64. If you don't have a graphing calculator, here's what you'll probably have to type. Type in 3. Hit the second button. And then find the button that looks like this. That means we want the 3 to be the cube root. Let me know if you need help. I'll walk around. Any need help? That looks right. Yep. Uh-huh. You actually have a button. Okay. Try that. All right, now that we have the sides ratio, we can fill in the others. This is going to be the exact same. This one is going to be squared. 3 squared is 9. 4 squared is 16. This problem is actually much quicker than the last one. This one just simply says, what's the scale factor, which means the ratio of the sides. We're done. All righty. Number 6, this should sound familiar. You are selling boxes full of air fresheners. You sell the smaller 2x4x10 box for 18 bucks. The customer would like the 6x12x30 box. Since you tripled the side lengths, you sold them to it for 3 times the cost of the smaller one. How much did the customer pay? How much should you have charged them? Explain. We don't have to explain in words. We're going to show our work in math. So let's write down sides, perimeter, area, volume. When you buy a box of air fresheners, are you buying one side of the box? Are you buying the perimeter of the box? Are you buying one side's area or the surface area outside? Or are you buying the inside volume? You're buying the volume. So what we have to do is remember, we are buying the volume, but what's listed are the side lengths. So Cam, pick a side, 2, 4, or 10. 2. Cam, what would 2 go with in the bigger box? 6. So our ratio is 2 over 6. We should always simplify. So a third. So the sides are 1/3 as big. Now that you have one ratio, fill in your other ratios. Match, square, and cube. 1 cubed is 1. 3 cubed is 27. Do you see which one you're going to pick? Because this $18, what does $18 represent? Cost for the volume, right? So go ahead and pick volume because we know one volume cost. The smaller box, which is on the top, the volume cost is $18. I'm going to put C. This will be the cost of the larger box. Connor, what'd you get? What was your original one on your paper from earlier?
486.
I thought so. Are we getting 27 times 18 is 486? No. That's how much you should charge them. $486. Some of you, when you saw this problem earlier, you had a good thought. You said, oh, these are all triple. So I'm going to take the $18. The box is 3 times bigger, so I'm going to multiply by 3, and you got 54. But here's what you forgot. The sides are 3 times bigger. The volume is not 3 times bigger. It's actually 27 times bigger. Here's a visual for you. I'll measure this out. This does not match exactly these numbers, but you will see what I'm talking about in just a second. This is a 4 inches by 4 inches by 4 inches cube. This is triple side length. So 4 times 3 is 12 by 12 by 12. So just like the problem up here, all of the side lengths are multiplied by 3. Can you tell that a lot more than 3 of these are going to fit in here? 27 are going to fit in here. You can see there's like 9 will fit in that back row, the 9 will fit in the next row, and the 9 will sort of fit here at the top. So this is why this lesson is really important, because without a visual, all but one of you probably would have sold them this box for $54. Because you're like, oh, triple sounds good to me. But you were actually just thinking about size. You didn't realize there was a big difference between sides getting 3 times bigger and what happens to the volume. So if this was your real job, Some of you would owe your company $400 some. All right, one more thing I wanted to show you guys. You can set your pencils down for a minute. I saw this and I thought, that seems a little off. Take a look at what I've highlighted and see if you can see why I think it's a little off. Thoughts? 8-inch pizza, $5.24. 16-inch pizza, $16. Does that seem like a ripoff? Because it's double, right? Yeah. Think about what we just learned today, guys. This is an 8-inch pizza. When you buy a pizza, where is the 8? What part of the pizza is the 8? Where does that come from?
The whole thing.
What do you mean the whole thing?
The whole pizza.
Circumference is 8?
Yeah.
No. The diameter. So like, you guys know TVs are measured diagonally, right? 54 TV, the diagonal is 54. Pizzas are measured by diameter. So this is an 8-inch pizza and a 16-inch pizza. That's diameter. Have any of you ever gone to Monocle's and when they bring you the pizza, they only bring you the diameter? They bring you like this slice and you eat it. No. Do you guys just eat the circumference of the pizza? Maybe some of you do if you like crust. Don't we eat the area of the pizza? Right? It's flat, so we're not really thinking volume. It's sort of flat. So let's think about this. Let me draw. I'm not going to measure, but I'm going to copy this so I know it's exactly double. So there's an 8-inch and there's a 16-inch. Now let me make a pizza with that diameter.
We're getting into that today.
Yep. All right, so does it look like just 2 pizzas are going to fit in here? A lot more than 2, right? Because you could cut this pizza up and you could fill this space over here and that space over there. There's actually 4 small pizzas that are going to fit in there. Here's why. The sides ratio. Now, I know this is not an outside, but it's a single dimension, so we still categorize it as a side because it's just one dimension. It was 8 inches, and this was 16, which simplifies to a half. So the sides, or diameter, are getting bigger or smaller, a half or by 2. The area, which is what you eat of the pizza, because it's flat, we'll say 2D shape. It's actually a 4th. There's actually 4 of these that fit in here. So let's find the cost of the smaller one, $5.24. Let's cross multiply. In your calculator, please take 4 times 5.24. Nora, let me know what you get. 20.96 should be the cost of the bigger pizza because it's not twice as big. The diameter is twice as big. The area is 4 times as big. It should be $20. Is that a good deal?
How much do they charge you?
That is a good deal. They only charge you $16. Are we understanding the importance of this lesson? You cannot compare what's happening with the side and say, oh, the area is going to be double also. That's not the way it works. You have to look at the way the sides, perimeter, area, and volume behave. That's why you kind of have to do it this way. All right. That's all I got for you. Good job, Connor. I don't think you did it quite this way, but you kind of figured out each side was times 3, right? When you did it?
Yeah. something like that.
Yeah.
Yeah, I did multiply